Now in this question, they said the diagram shows a solid cone which has a slant height of 15 centimeters and a vertical height of 8 centimeters. The slant height is 15, vertical height is h. Show that the volume V centimeter cube of the cone is given by V is equal to 1 over 3 pi times 225 h minus h cube. The volume of a cone of radius r and vertical height h is 1 over 3 pi r squared h. So we need to express that volume in terms of h, and they've given us the formula for volume in terms of radius and height. So we need to first figure out an expression for r squared in terms of h. So let's see how we can do that. Well, we know that the radius of the cone is simply r centimeters, right? And the height of the cone is simply h. And we have a right angle triangle over here. So we can use Pythagoras' theorem, which says that the sum of the squares of the two right angled sides, the opposite and the adjacent, is equal to the square of the hypotenuse. So we can say that h squared plus r squared is equal to 15 squared. So that means h squared plus r squared is equal to 225. Now what that means is that we can say r squared is equal to 225 minus h squared. So now we have an expression for r squared in terms of h. R squared is equal to 225 minus h squared. Now if we plug this into the formula for volume is simply 1 over 3. The volume is simply 1 over 3 pi r squared h. And we know that r squared is simply 225 minus h squared times h. And when we expand this and simplify, what we get is 1 over 3 pi, and then h times 225, which is 225h, and h times h squared, which is minus h times h squared, which is h cubed. So 1 over 3 pi times 225h minus h cubed. So that's your volume of the cone. Now part 2 of this question says, given that h can vary, find the value of h for which v has a stationary value. Determine, showing all necessary working, the nature of the stationary value. So now we already know that the volume is 1 over 3 pi times 225h minus h cubed. And when they say that the value of h for which v has a stationary value, what they mean to say is that the change in volume with respect to h is equal to 0. So that means that dv over dh is equal to 0. We need to find the value of h for which dv over dh is equal to 0. Now let's calculate dv over dh then. Well, 1 over 3 pi is just a constant, so let's just leave it out. 1 over 3 pi. 225h, the derivative of that is simply 225. And minus h cube. So the derivative of minus h cube is simply, you multiply by 3 and then decrease the power by 1. We already know this. So this is minus 3h squared is equal to 0. Now let's try to solve for h. So we can get rid of this 1 over 3 pi over here, simply because if we just take it to the other side, if we divide both sides by 1 over 3 pi, we simply get 225 minus 3h squared is equal to 0. That means that 3h squared is equal to 225. So therefore, h squared is equal to 75, and h is equal to square root of 75. We're not going to take the negative square root because h has to be a positive value. So it's just the positive square root of 75. Now we have to figure out the nature of the stationary value. Now, that means we have to figure out whether the stationary value, when h is equal to square root of 75, we already know that we have the change of volume with respect to h is equal to 0. But is this a maximum or a minimum? And we can do that by taking the second derivative. If the second derivative is negative, then it's a maximum. And if the second derivative is a positive, then it's a minimum. So what we can say is that if we take the second derivative here, which is d squared v by dh squared over here, what we have here is this guy over here, 1 over 3 pi times 225 minus 3h squared. That's the derivative. We have to take the derivative of the derivative. So here again, 225 is a constant. So this constant term disappears, minus 3h squared. So what we get is, for the second derivative, we get 1 over 3 pi. We get 1 over 3 pi times minus 6h. We get 1 over 3 pi times minus 6h, because 2 times minus 3 is minus 6. And then we just decrease the power by 1. So what we have is 1 over 3 pi times minus 6h. Now, if you see h, if you plug in this value of h over here, what we end up with is a negative value. So we know that the second derivative at this particular value of h is a negative value. That means that this stationary point must be a maximum. So that's your answer.